Today we are going to do an experiment to find out the value of Km and Vmax. For that we are going to do enzyme activity for our enzyme, and these are our solutions. Stock solution, we are having 3 different stock solutions for that of the substrate, so that we could have the larger range of points that we could plot and get a perfect graph. We are using stock solution of 0.1 millimolar, 1 millimolar and 5 millimolar. Then we have next reagent as acetate buffer, so that we could maintain the pH at 4.5. Then we have MgCl2 which will act as a cofactor. We have our enzyme and NaOH for stopping the solution, stopping the reaction. First of all, we will start at the first stock solution. What we are going to do is we are going to take 3 alicos with this solution, stock solution, as 0.2, 0.4, 0.6 ml in both blank as well as the test tube. And then again, we'll take the second stock solution with 0.2, 0.4, 0.6 in other 3 tubes. Then with 5 millimolar solution, 0.2, 0.4 and 0.6 ml in both test as well as blank. So first of all, we'll take the stock solution, the first stock solution, that is 0.1 millimolar. Aliquot first, that is 0.2. In my first tube, I'll take 0.2 ml of solution, 0.2 ml in the blank. Then I have to take 0.4 in the next. In the same way, 0.4 in the blank and 0.6 in the next. As we have added with the stock, for stock 0.1 millimolar, we add with stock 1 millimolar, 0.2, 0.4, 0.6, 0.2, 0.4, 0.6. And also the third, from the third stock, 5 millimolar, we'll add 0.2, 0.4, 0.6. The same way we have added in the first tube. So this way we have added the alicos as 0.2, 0.4, 0.6, 0.2, 0.4, 0.6, 0.2, 0.4, 0.6, respectively from 0.1 millimolar, 1 millimolar and 5 millimolar of stock solution. Now we have to add acetate buffer, which will maintain the pH at 4.5 with a concentration with an amount of one volume of 1.8 ml, 1.6, 1.4. What we are doing basically is just maintaining the level to 2 ml. So as in our first tube, we have added 0.2 ml of substrate, we'll add 1.8 ml of buffer. The same way with the blank. Then the next tube, we have added 0.4 ml of substrate, so we'll add 1.6 ml of acetate. Same way in the blank of second tube, 1.6 ml of acetate. Now in the third one, we have added 0.6 ml of substrate, so we will going to add 1.4 ml of acetate buffer to in the blank of the third tube, 1.4 ml of acetate buffer. In the same way, I am going to add 1.8 ml, 1.8 ml in E4, then 1.6, 1.6 in E5, E5 and B5, black 5, and 1.4 and 1.4 ml in E6 and B6. The same way as we have done in the first 3 tubes, the next tubes will be given the same amount. In this way, we have added acetate buffer with 1.8, 1.6, 1.4, 1.6, 1.8, 1.6, 1.4, 1.8, 1.6, 1.4 ml in each tubes. Now we are going to add the cofactor, that is MgCl2, with a concentration of 0.1 ml in every tube. We have added the MgCl2 in these 6 tubes. We'll add 0.1 ml in every tube. So now we have added 0.1 ml of 1 molar MgCl2 in each tubes. Now we have to add our enzyme with 0.5 ml in each tube of test, not in blank right now. Right now we want just the reaction to take place in our test tube. We'll add 0.5 ml of enzyme to each, that is E1, E2, E3 till E9. The same way we'll add 0.5 ml of our enzyme in all the 9 tubes. We have labeled as E1, E2, E3 till E9. Now we have added the enzyme in each test tube, that is from E1, which we have labeled as E1 to E9, and after proper mixing of each the tube in which we have added the enzyme, we are going to incubate these all tubes at 37 degrees for 30 minutes. So now the incubation is over. We have incubated all the tubes at 37 degrees for 30 minutes. Now what we have to do is we have to add NaOH, 1 normal, in all the tubes to stop any further reactions in the tubes which have the enzymes. So we'll add NaOH 0.5 ml in every tube. In the same way, we are going to add 1 normal NaOH in all the tubes. So we have added NaOH 1 normal to all the tubes, and we can clearly see the color gradient is increasing with the concentration of the substrate we have taken. As within the first 3 tubes, we have taken 1 millimolar 1 millimolar stock solution for the substrate for the 0.1, and then for the next 3 tubes we have taken 1 millimolar, and for the next 3 tubes we have taken 5 millimolar, and the color is according to the concentration. Now what we have to do is we have to add enzyme to the blank tubes, that is on the back side, as we haven't added enzymes to them, to make the volume equal. In the same way, we add 0.5 ml of enzyme in all the blank tubes, taking from B1 till B9. Now we have added the enzyme to all the blank. Now we can see here are the blank which are not having any color because the reaction will take place in them, and in these tubes from E1 till E9 we can see the color gradient. Now what we have to do is we have to take OD of all these tubes at 410 nanometer, and we will plot the graph according to the OD which we get in different concentration of the substrate, and we'll get the value of the highest, the line at which the velocity will be the maximum. The half of will give us the half of Vmax, and from that we can get the Km substrate value. So what we have to do is now taking the OD of all these tubes at 410 nanometer and plot the graph of enzyme activity with the concentration of the substrate which we have used.